All right. So right before the video started recording, I was expressing my excitement about this class. I've been wanting to teach it for a long time. I really enjoy game development. I think it's a very fun thing to do. I really enjoy making games. So I've been wanting to teach this class and been excited for a while. So every time 1 o'clock rolls around on Monday or Wednesday, I'm uh, kind of jumping with excitement to get started. And well, we've got quite a bit to cover this week because there is a lot involved in game development. Uh, so the plan is today we're going to finish out the PyGame stuff. We're going to add a couple touches on what we did last Wednesday for the class example. And then we're going to talk about object-oriented programming conceptually, and then we'll adjust that game that we started last Wednesday. Well, I should put quote marks around that. The game we started last Wednesday, we'll adjust that to object-oriented programming, at least on a couple things as time allows. Because as always, I want to make sure there's lots of lab time available to do stuff when I am sitting here by my computer waiting for the phone to make a noise in case somebody has a question. You can ask me questions anytime, but during the scheduled slots, there's some time slots that y'all know the schedule of that I am just sitting by a computer waiting for somebody to ask me a question. So I'll make sure there's plenty of that. And we got a lot to cover today. And then Wednesday starts module 3, which means we're going to move to another game engine. It's a really easy one to use. It's been around for a long time. A lot of people have started out with it. I wanted to start with a scripting one and then move to it. And there is scripting capabilities to it when we get there, but it's been around for a long time. They kept adding more and more and more buttons to the graphical user interface, so we can pretty much do the entire thing with our mouse and let the computer handle the tedious task of writing the code in the background, and we just have to put together the algorithms, which software development in general is becoming more and more and more of that every year. The computers never make typos. So if we have the computer type the code for us, we don't end up with all those typo problems that happen when we try to type computer code. And the human is just needed to put together the algorithm, tell the computer what code to write. So we'll see that stuff we'll get started into the module that includes that on Wednesday. We're actually going to start with graphics and start and kind of try to squeeze in some basics about 2D and 3D graphics and animations as much as can fit in a day without making it, without sitting here for the full 4 hours of bombarding you with information. Because one of the pieces of software we use in then is called Blender. And for using software like Blender, that's not a class period. That's not a semester-long class. Something like software like Blender, fully functional computer-aided design software, that's more of a college degree. So we're going to try to get a quick preview in it. Hopefully make it so you're not so scared of all the buttons, because there is a lot of things that can be handled. But it's very powerful software, can do some amazing graphics. We'll talk about that on Wednesday. So today we got a couple things. Well, Wednesday and Monday. Wednesday and the next Monday we'll be doing graphics. One of the things for today is an animation. I sent out some files right before the class. You may have noticed in the message when I sent that file out, is it's an animation of that character, or not the same character, a different character, but similar, just scratch character. And I wrote in that message that I only spent 10 minutes on it. It's not a super nice one, but it's a fully animated image to give us a better feel of what that thing we started putting together last week will look like with animations. And you might think, well, there's 20 frames in that animation. That's only 10 minutes worth of work. And well, the 10 minutes also included recording the sound for sound effect thing. But it is very, very quick. It's a whole lot quicker to draw one image and just tell the computer we want that image animated than it is to draw all the frames. But that's what we'll be looking at Wednesday. For today, let's finish up our stuff with PyGame. We'll start by adding in some animations to that character, so it's not just a still image moving around the screen. Which, just a reminder of a point that I made last week, that when you start off, you probably want to use still images. Some people even take that to the extreme and say you should start and put your code together and test your code with like rectangles and circles, because the same reason stage magicians seem to be able to do so much. A little bit of distraction goes a long way with humans, and very, very large bugs can hide behind very, very small animations. So it's good to check for the bugs with still images. So I went ahead and downloaded the files that I put on Ivy Learn, the ones from last week's example, because that's our starting point here. And my video looks jumpy. Can you all hear me?
Yeah.
Yeah,
Okay.
we can hear you.
Yeah.
Okay, yeah, I'm still nervous about that from last week because that hasn't happened again, so I haven't really had a chance to, can't troubleshoot a computer when it's not, when the issue isn't occurring. So still makes, I'm like nervous things are gonna cut off and my video got all jumpy. So I downloaded the files to start with, so I'm gonna copy them over to a working folder. So here's the new ones. This folder of animations, just nothing fancy, just a scratch character and 20 different frames to represent an animation. And what I called coin sound, I have a huge percussion set. I have a huge room full of instruments, but one of the things in there is a percussion set. So I just grabbed one of the handbells and just kind of shook that really quick. It's like, yeah, that kind of sounds like a coin falling into a pile of coins. That'll work. So I'm going to copy these files over to a place to work at. Oh, it looks like I didn't delete the example when I was preparing, so I could have just grabbed them from there. Class example on animation and sound. And also, I'm going to grab the files from last week because that's, oops, that's not last week's files. The files from last Wednesday that I sent out after class, because that's sort of our starting point here. Open this up with a text editor and shuffle things around here. Is I can't remember if I've said it before or not, but the chalkboard here is actually just in my gym. That's where I like to do my math problems. I'll write the problem on the board and then stare at it while I work out. And it has become very, very useful for Zoom calls. So I'm actually in my gym here, and instead of a desk, I have several bar stools. So I often have to shuffle things around because there's not much room on a bar stool. So this is where we were last week. Should be, I added in some comments describing things. I'm gonna take them out of here to make this a little smaller to start with. Let's see, this is the next one. Comment there. And a comment there, which was the stuff from after class. I added in some comments, just another quick pass at the concepts we looked at. So I'm going to open up PowerShell. That's it has all the same functionality as the old command prompt. They just expanded it so that it does more and includes what has become a standard scripting language. One of the big issues that I really liked is back in the 1970s, 1980s, when command prompts and bash terminals and all that was invented. RAM was a very precious commodity, and we didn't want to waste that on computer experts that knew what they were doing. So everything was abbreviated. But come the early 2000s, that was no longer necessary. So that was the first update to PowerShell, is get rid of the abbreviations and actually spell out the words, because typing is easy. They did some other stuff, like if you're familiar with the command prompt instructions, to show the directory listing in Windows is dir, whereas on a Unix-based system like Linux or Mac, it's ls. And they added some of those Linux commands in to make things easier. We don't have the typos because from jumping back and forth between systems and forgetting what our command is in a particular operating system. Let's see, what folder did I just create? So change directory into class, example, animation, and sound. So yeah, here's the one from last week, which I'm going to save as a different, well, I'll run it now first. So Python interpreter, we want to start that and run the in-class example for events.py script. So this is where we were last week. I didn't turn on the sound when I shared the screen, but y'all probably remember when we run into it, it just silently moves to another spot, which is definitely something lacking. And it doesn't at all look like that character is really walking per se. We're just moving that image around. So that's the two big things I wanted to include today. So first thing I'm going to do is give this a new name, a relevant name. Save this as in-class example, animation sound. I'm going to abbreviate them. So in-class example for animation and sound. So the first thing, well, our background, that's not really changing. I'm just going to leave that like it is for the rest of the updates on this game. But our player image, our player sprite, well, it's obviously not animated because we only loaded in one image. So what we really want to do is, instead of loading one image, we want a big collection of images. We want a whole bunch of them. So instead of a single image stored in that, I'm going to turn that into a list. And one thing with Python and in a lot of our languages, we can split up our lines in certain spots. In a lot of languages, it doesn't matter, but Python includes what we call significant white space. So there, our white space does matter, and we can't split up a line just anywhere. But when we create a list of things in Python, it's sort of a comma separated list, and we are allowed to put line breaks after the elements in a comma separated list, because otherwise that list would just get really, really big and make the code hard to read. So I'm going to go ahead and split this up and load the images in this way. As far as loading an image, there's no difference, right? We still need that method. Oops, not player. The PyGame library has an image object. We're going to talk about objects today, so I'll make sure and use that word. And that image object has a method called load in it. And then we just need to say which image we want to load. And then we're going to make a big list of them, so it'll be a comma separated list. And we're allowed to put line breaks after a comma separated list to make this a little easier to read. So what is the image we want to load? That's in this folder that I sent out, these player walk images. So player underscore walk underscore 0001, first one. And we actually want to do all of these. So A computer generated these, and even if you're doing the full animation by hand, frame by frame, which is very time consuming, but I would still recommend doing one at least once. It helps to develop a better understanding, but it definitely does not fit in the time constraints of our class here. We're going to have the computer generate a bunch of images, so we'll get names like this. Everything's nice and organized. The only difference in the name is which one of the generated images from the set it is. So in the player walk folder is this file player underscore walk underscore 0001. So that'll be the first one to load in. And well, really we want to load all of them in, and there's 20 of them in there. So with the file name, which file names are always a string, pretty much always a string. I only know of one common exception to that. Whoops, that's not where that went. That goes up here. In the pygame.image.load for our player sprite, file names are always a string, as well as the directory path leading to them. Previously, we just said load in this file because it was in the same folder. We didn't have to go, the computer didn't have to go looking for it to find it. It's like, oh yeah, the file's adjacent to this script in the same folder. But here we have to go into another folder, so we do need the directory path. And we can use relative addressing, which means that we can send in the directory path starting at our current location. So our current location on that Python script, those names aren't very good. I need to delete one of those. This one. Don't need that in this folder. So starting at our current location for this script, we're going to go into this player walk folder and then grab one of those files. So we need to go into the player underscore walk folder, and this is something that's different on our different machines. So on a Windows machine, it should be a backslash, which means something to the code. Notice how it no longer has that colors for a code. So that means 2 backslashes, because then we need to, that means something for the code. And what it means is to escape out of coding, escape out of any code symbols. So on a Windows machine, we should be doing it like this. But we don't necessarily know for certain if this game is going to be run on a Windows machine. So for the Python language, we usually do the Unix style with the just a / instead of a backslash, which we need 2 backslashes because that means something in our code. So for Python, we do a /, which is Linux or Mac style. And then if we're on a Windows machine, the Python interpreter will handle that adjustment. And that way we don't have to worry about what type of machine we're running on. So we're going to go in the player walk folder, and in there is a file called player walk 0001.png, which were all just generated files. So they're all going to be very, very similar. So I'm going to copy and paste this line a whole bunch of times. So I hit the N key to put my cursor at the end of the line, and then hold Shift and Home. That'll highlight the whole thing. So I can hit Control C, and there's 20 files, so I need to paste this in 20 times. 2, 3, 4, 5, 6, 7, 8, 9, 10, 18, 19, 20. And the very last one does not need a comma. The commas just go between things. So I'll paste that, copy and paste that 20 times and erase that comma. And now the only difference is that number. So I'm just going to go down here and adjust those numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And since I'm doing a column thing, I'm going to deal with it one column at a time. I'll do this column, and then I'll come back and do the tens place column. That way I don't have to hit backspace more than once on each time down. So just scroll down, backspace the next number, backspace the next number, backspace the next number. And this way I'm not constantly changing my frame of mind. Then this last one is 20. And now I'll deal with this other column. So 19, 18, 17, 16, 15, 13, 11, 15. So that's the only difference there. And that's just a recommendation that I found over after years and years of programming, is a lot of times we end up with things like this. And a lot of times there's more than one change in the line. So it can be a lot more productive to kind of go down the columns than to go across. But still pretty much just a copy and paste thing. We stick the first one in there and then do a whole bunch of copy and pasting. But now there's some editing we'll have to do before we run this. I'll go ahead and come over here and throw the error message. Oh, that's not the error message I was expecting. Did I get a typo in there? Oh. I thought I'd already run this one. Sorry. Let me try this again. Open the Python interpreter and run whatever our file's called there. Python in class example and sound.py. Okay. Now I should be able to just hit that button. Okay, here's the error message I was expecting. Attribute error. List object has no attribute get rectangle, which is in line 48. So if we come back over to our code, we'll see on line 48, this is where we get the bounds for our rectangle, that the edge of our character, so we know when it collides with something else. And the problem is, previously player sprite was a single item. There was only one image there, but now there's 20 images there. So well, in this case, they're all generated images, so they're all the exact same size. So I just need to refer to any single one of them. So I'll just use index 0 of that list instead of lots of them. So I should run a little bit further, but you probably already realized it's going to throw the same error message again, just in a different spot. Yep, type error. We gave a list where we should have sent in a surface, which is what the developers of PyGame referred to as a block of pixels for our block transfer, the blip method. So apparently we sent in a list when we were supposed to send in a single item. So you probably saw that coming. So any place we were referring to the image, now we need to change that. And there's a couple ways to do it. One of the best ones, is this sort of thing happens a lot, is to push Control H. That's our find and replace. In some of our text editors or IDEs, that might be Control R, but it's Control H in more of them than it's not. So I usually don't even bother to remember. I hit Control H, and if that's not find and replace, I'll try Control R. And it's usually one of those. But then we can find anything that says player Y and replace it with, oh, whoops, that's not what. We can look for anything called player sprite and replace it with player sprite index 0. In a lot of cases that'll work. I'm not going to do that this way. I just wanted to take the first opportunity I could to point at the find and replace box, because once again, if the computer does the typing, computers never make typos. And you may have noticed that picked player Y there as the thing to look for. And that's simply because that's where my cursor was. If I put my cursor over here in player bounds and hit Control H, you'll see it's trying, it thinks that's the word I want to look for. So we don't usually have to type the look for word. The computer can predict which word we want to look for based off where that is. Along with find and replace, we also have a simple find. If we hit Control F and just look for wherever player sprite shows up. Oh, here's one, so we better change this because we don't have a single image anymore. Line 92, that's where the thing happened. So we have a whole animation. I'll go ahead and do the whole thing. We don't want to play just one frame, right? We don't want to show just one frame when that game's going. That's what we had before. We want to show all of them. So we need a way to tell what frame we're on. And I'm going to do that with a frame counter. So player sprite is now a list instead of a single element. So instead of showing just that one particular frame for it, I'm just going to figure out which one's needed each time, because I'll keep a counter running. We'll set that up here in just a second. Sort of that point I've expressed before, that the computer needs our code in a certain order, but that order the computer needs it in is probably not the order we think about it in. So we end up with a lot of bouncing around back and forth. And that kind of helps the code flow out more naturally if we just let ourselves bounce around and put the code where it needs to be when we realize we need it, instead of trying to predict ahead and put everything in order like we would writing an essay or something. So I'm just going to have a frame counter running, and well, there's only one animation here, so it could just go up to 20, but usually we're not in a classroom example under tight time constraints, so there's going to be more than one animated thing in the game. So what I personally like to do, instead of keeping multiple counters, is I'll keep one counter and choose the modulus operator to restrict that to a certain range. Just remember, if we take a number mod 20, that's going to give us the remainder when we divide by 20. So the remainder will be some number between 0 and 19, which correspond perfectly to the indices of our player sprite list. And now we just need to set up that frame counter. So I'll come way up here to the initialize stuff, and that's going to be kind of a big one. So I'm going to start it at 0, way up at the top, somewhere before we actually need it. Just frame starts at 0, and then I'm going to come way down to the bottom of the main loop. And right before we finish the main loop, the last thing to do is, well, at this point, the next frame's set up, so we're going to update the animation, and somewhere around here we need to increment our frame counter. So I'm just going to do the assignment operator, or I often like to think of it as the reassignment operator, because the reason we had to scroll way up to the top there and put the variable up there is we cannot do an initial assignment with an assignment operator. We have to have that frame equals the starting point, and then we can reassign it. But we can't do that initial assignment with a reassignment. So does that logic make sense? Just a counter that's just going to keep running for as long as the game does, increments every frame we hit, and we'll just take it mod 20 to restrict that down to the number of indices we need for our list of images. It's the basic logic there. So now we have a walking animation. So if the character moves, looks like the speed of the animation could be quicker, or the speed of the movement could be slower, but there's always going to be little adjustments like that. Right? Also, the turned around thing, we'll do that here in a second. But when he hits the coin, it's still the same. And when I let go of the keys, he should probably stop walking, right? I'm going to skip the speed animation, but can I get some confirmation? Do y'all see what it would take for that adjustment? Looks like our animation and the actual movement's a little off. So we either need to speed up our animation or slow down the speed the player moves at. Either one would balance that out. But that should be an easy, and that's going to be unique for every game. So that's something you're going to do every time as well. So that really comes down to just a little bit of trial and error to find the right numbers for your particular game. Because every one of them does have a lot of unique qualities like that. The general logic is just find the middle ground where the animations and the movement match up nicely. I'm going to ignore it for the class example here. If it seems like we have time here in a few minutes, we'll come back and get that. So what would be a good first one? So first off, let's stop the player when he doesn't need to be walking. We only need that animation when the player is moving. If the player is standing still, he should probably be standing still. So there's lots of different ways we can apply this. What I like to do, I feel it relates back to readability and code and things like that. Up here where we define all our variables for the player, I'm going to add one in for the player's state, the current game state as it relates to the player. What is the player's state? Because when we just start off, the player's not going to be moving, so he'll be in an idle state. And there's a lot of wiggle room here. Some people like to use numbers. Personally, I like to use words because I think it makes the code a lot easier to follow along with, which if it runs, that's no issue whatsoever. But when we have problems and need to debug code that is easier to follow along with is going to be easier to debug. So I like to go with words, and then we can just check and see if the state is that particular word. Because that's going to change at points, right? When we start, it'll be idle. But if we push the W key, we want that player to be walking. So whenever that key is being held, we'll change the player state. Player state equals walk. I'll just use those two. He's either idle or he's walking. And that gives us a nice little condition we can check. Player state equals walk. And that needs to happen in all of these keys. Player state equals walk. Player state equals walk. Oops, that's a string. Almost made a typo there. And that way, if the key is pressed, so the player is moving, we should be seeing that walk animation. And when the player is not moving, so we have a key down event. That means when the key is pressed down, the player is going to be walking, and the player needs to be not walking when the key is released, which is a key up event. So we'll want to add that to the list. Oh, I guess I could have done that walk right here as well. Just in the thing that happens every time there's a key down event, we update our bounds. Well, all of those keys do the exact same thing, so we could have put that in the overall place instead of in every one of those nested conditions. But that's all the stuff to do when the key's pressed down. So alternatively, the next thing in our loop through all of the events that happen is we can check and see if the event.type is a PyGame key up event. And obviously it's not necessary to memorize all these right off the bat because we can look them up, or the ones we use a lot, like key down and key up. Those will kind of get committed to memory eventually anyway. We can just copy and paste the other one. We knew the key down worked, so key up seems like it would be a reasonable guess for releasing the key. And at this point, when the key is released, all we really need to do is change the player's state back to idle. So when the key is down, the player is in a game state of walking. And when the key is up, the player will be in a game state of idling. And then we can just choose between those for which animation we show. So if player state is equal to walk, oops, that's when we're going to check all of them. But if not, so in our case, it's really an else. But to help generalize this, in most situations, we're going to have more than just two states, right? The player could be standing still, the player could be walking, the player could be jumping, the player could be running, the player could be throwing a fireball. There's probably going to be more than two. So instead of an if else, I'm going to go ahead and do our example here as an if else if and put the other condition in. It just so happens at this current time we only have two of them. And then once again, I'll copy and paste. So I'll scroll up here and use the home and end keys to select the whole line at once. Paste that in, and the only thing that changes is which index we need to see. I'll just go with 0, whatever the first frame is. But as a general rule of thumb, when it's not a super generic example, you'd probably want to open it up and choose the best idle state. Kind of like, well, might as well go ahead and do that. I guess it looks like 10 would make a nice idle state. That looks more like standing still. Actually, that looks very rigid. That looks like standing at attention. I guess I'll go with 0. Yeah, to make this animation, all I did is that was the original picture. So I put that as the very first and last, and then one frame past where it stopped. So frame 1 and frame 21 are the same. And then one of these around here, probably that one. But somewhere in the middle, like that frame and that frame, I told the computer what positions to be in at those points, and then it filled in the rest of them. So it's a very, very quick process. It's going to take us a minute to explain the whole thing on Wednesday. But it makes animations a whole lot quicker. And I'm trying to jump ahead. I'm all excited about that as well. So back to the current moment. Does this make sense with our game states? One of a major vocabulary term in video game development, the state of the game, and not just the object state as well. We need to know what the player should be doing so we can bring up the appropriate animation. And in some situations, depending on the state of the game, we might have a different set of things to happen when a collision happens if we're walking as opposed to when we're standing still. Okay, I assume the silence means no questions, so I'm going to go ahead and run this and see if I made any typos, because I was talking the whole time I was typing. Okay, looks like it starts out okay. He's standing still, and then when I push over, oh, looks like it worked. Going up and down, and we get a little, starting to get some movement going on in the game. Push the key and release the key. He walks or stops walking appropriately. It doesn't matter whether we go up or down, left or right, he's walking. But the next thing we might want to address in this animation is that that moonwalk's kind of strange, right? Depending on the game, maybe it is appropriate for your character to look like he's moonwalking when he goes backwards, walk backwards without turning around. But I think for our little, again with quote marks, game here, I'll have the character turn around. And that is really, really easy. The worst case scenario is we actually have to use our transforms to code that in. That was mentioned earlier, so a reminder on that. A transform is our position, rotation, and scale locations. Your first instinct is probably that the rotation turns it around, but it's actually the scaling. Because like if we have this thing, a character that's this big, and we scale it by times 3, it's going to get 3 times bigger. A fraction, like divide scale of dividing by 3 or multiplying by 1/3 would make it 3 times smaller. Those are all positive numbers. When we scale in the negative direction, that comes past it and flips us across the axis. So in the negative x, scaling in the negative x direction, it's like scales our image down and then goes back in the negative direction. So that's how we flip things around horizontally and vertically with the scaling. Rotation is more for turning. Rotating the way we're looking at it, and scaling would flip it across our horizontal or vertical axis depending. But that's a really easy thing, because if we just want to turn it around, all we do is scale by -1. In the worst case, because that's a really easy thing, so pretty much all of our game engines, they already wrote a method that does that, because it only took them a couple seconds to write a method that scales things by -1, and then we can put in words like flip, which make more sense, which is also our word in Python. In PyGame, there's more than one game engine in Python. Personally, I like Panda 3D a little bit better for just like PyGame, we can do 2D or 3D games there. The biggest difference is Panda 3D was developed by Disney when they made Toontown Animation or Toontown Adventure. It's built in, it's Python, it's a really nice one. The documentation is awful, because when Disney had all the developers working on that and developed the engine for that game, they were all in the same room, so they didn't really bother with documentation much. And after that initial project, after they finished the project they made it for, they basically assigned 2 or 3 guys to write the documentation. It's 10 or 11 years later now, and they're still working on that. When there were several hundred programmers on the project, would have been a much better time to write the documentation. But a huge, massive project built by several hundred programmers, and then afterwards they assigned 2 or 3 guys to write the documentation, and they've been working on it for like 10 years. So it's getting better, but it has PyGame on the other hand has excellent documentation, lots and lots of official reference material and unofficial reference material, and it's very common to start off with. So countless YouTube videos, tutorials on PyGame. So that's why I chose it for the class. Got a little distracted there. Okay, yeah, so we want to turn our character around, and that method to turn the character around is built into PyGame just as flip, which all it does is scale in the negative. Flip just scales by -1 in either the X or the Y direction. So an easy thing if we have to go all the way back, but it's a small thing, so pretty much all of our engines include it. And this is a 2D game, so there's only 2 directions we can face, right? Well, I guess in theory you could go 4, so you do things, but with 2, whenever it's just a left-right thing as opposed to an overhead thing where we turn in any direction. For left-right, I just like to do that with a simple Boolean. So I just pick one of them randomly, which usually I go with left, because it seems like player right could be taken in more than one word, more than one way. There's more than one meaning for the word right, but there's not so many meanings for the word left. So I usually go with left instead of calling the Boolean right. But our initial state, it looked like the player was facing to the right. So I'm going to start that Boolean at false. And if we need to turn around, then we can switch that to true for the players facing left. So just a Boolean to keep track of whether we're facing to the right or to the left. And if you need 4 directions, like up and down, left and right, or maybe 8 directions to include the diagonals for your character and sort of an overhead view or something, then maybe numbers might work better than Booleans. You just give each direction a number and check that, but the logic is very, very similar. So we have that. So we have a Boolean. So we just need to figure out when to switch it. So on our controls W, that's going up. So it doesn't matter if the character is facing this way when it goes up or facing this way when it goes up. He's going to go up the same way. So we don't need to switch it on up or down. They can stay whichever direction the character was already facing. A would need to change. So I'll add another one here on this line in this condition. So if the A key is pressed, that moves our character to the left. So the player should be facing left at that time. Player left is true when the A key is pressed. S is an up or down thing, so just whichever way he was already facing will be fine there. And D is to the right, so when the D key is pressed, that's when we're going to want to change. Oh, not state. Well, it is still part of the game state for the player. We're going to want to change the player left state. Player left Boolean defining the player facing state. Which direction is he facing? And if we push D, that's to the right, so left will be false. And then we can just flip our thing depending on if we want that to happen. And it's really nice to do this as a Boolean because our flip method actually needs Booleans. So we could do another condition here to just check and then flip the sprite accordingly. But I'm just going to go ahead and flip the sprite every single time because one of the arguments we need to pass in is a Boolean. We're going to say true or false for flipping across the x-axis, or sorry, flipping in the x direction, which is across the y-axis. And then we're going to say true or false for flipping in the y direction, which is across the x-axis. So for left, right, we need to flip across the y-axis, which is the x direction. So we'll add in this method PyGame transform, I think. I have an example pulled up. I should double check it. Yeah. PyGame.transform is flipping is part of transforming our image around the scene. The location, rotation, and scale are transformed. And one of the things we can do with the transform is flip it. So PyGame.transform.flip. Then our first argument is what do we want to flip? The player sprite, whatever frame we're looking at. Then our second argument is, are we going to flip in the x direction? Which that's the one we need here. So we can just put in player left. So that Boolean is either true or false. So if it's true, the player should be facing left. Then it's going to flip it and the player will face left. But if it's false, it's going to keep it in the initial state and the player will face right. And that's pretty consistent that we don't have to do every single picture we need. Right? Things like facing left and facing right are symmetric enough that we only need to draw one set and then we can just mirror them if we need the other one. And for our thing here, we're not going to need to flip across the y-axis at all, so I'll put that as false. And notice that went before the comma for the blip method. So all of that is the full, basically taking the place of, it's not going to fit there, is it? Maybe if I'm to full screen. Yeah, that'll fit. So that whole big method there took the place of what did just say player sprite. So instead of just player sprite, we're going to say flip player sprite, either left or right, but not up or down. And that's what takes the place of that whole thing, which was a lot to type. So I'm just going to copy that for the other one. I'll hold shift and use my arrow keys to get in the right spot, but and the thumbnails on the screen. And here, the only thing that needs changed is if we're standing still, we only need one of our frames. We don't need all of them. Any questions about that? Hopefully that logic's straightforward. It's just because flipping it or not is a true or false value. So we just stored that true or false value somewhere, adjusted appropriately with our key presses, and then throw it in to say whether or not to flip the character or to flip the sprite. Uh-oh. A name error means it's either something that didn't get recognized or a typo. Play E left seems like a typo. Line 107. Which is right here. And that was a copy and paste thing. So the place that it was copied from also needs adjusted. But typos happen. I'm often surprised in the class examples that they don't happen more often than they do, because typos happen when we're just typing. And in the class examples, I'm usually typing and talking the whole time. Okay, so pushing D to go to right, that works like it did. Up, down, might as well grab that coin. Those work the same, but left should be different. Yep. So that makes the movement look a little bit better, right? A very stripped down, trivial example for the classroom because we're under tight time constraints, but hopefully that logic is enough that y'all can run with it. I saw at least one thing got posted on that new discussion board for sharing your practice work. It looked really great and just a perfect example of taking the class example and making it your own. Because that's how we really learn things, make changes. Just have the class example as a starting point. Change things around, add stuff to it, modify it, make modifications to figure out what works and what doesn't work, and kind of make it your own thing. And yeah, then there's a discussion board to share those with your classmates and talk about them. If you come up with something really neat, some of your classmates might ask you questions about it. There's at least one on there if you want to check that, if you haven't checked that out yet. Any questions about that? Oh, something in the chat room. Python indentation problems. So the white space manners do have to kind of look at those. So in the general rule of thumb is every time we hit a semicolon, or sorry, not a semicolon, every time we hit a colon, we add a layer of indenting. So here in our main loop, we hit that colon, so then we start indenting everything. And then the first thing here is another indent. So we throw in a colon and things get indented. And that repeats for everything we need, and then we come back out a level. Everything we got to do and just keep indenting if there's a colon, and come back out if there's not. And the first thing I do whenever there's an indentation error is I try to let the computer fix it if it can. So Notepad++ doesn't, but most of our text editors, if we're in Python, it knows about that indenting. And a good IDE also knows about that indenting. So my first suggestion, anytime you hit an indent error, is put your cursor at the beginning of that line, just anywhere on there. And if we hit the home key, that moves it to the beginning, or it toggles back and forth across that indenting. So if you hold shift, you can select that, all that, and then backspace to get back to the previous line and redo the indent. Most text editors and IDEs will automatically do that indenting in Python, but Notepad++ doesn't, so I have to come down and hit tab once. So that's my first suggestion whenever you hit those problems. Do you want to try to share your screen and we'll go over some problem tracking down things?
Yeah, sure. Okay, so this is what I've got. I've tried doing this. I just kind of, it does that same thing where it
and then hit
indents it
backspace
into
once.
that. Yeah, and then save that, run, and it still says. I had this problem the last meeting we had last week where I was trying to follow along, and I couldn't figure out why it was doing indentation wrong or anything like this.
Okay. Yeah. So whenever this happens, stop me immediately, because tracking down problems is one of the best things we can do in the course, right?
Mm-hmm.
So my thought is maybe that needs to happen on every single line.
Yeah, because I've had, when I was doing Python earlier, like for my Python class, I ran into this error a whole lot using this IDE where it just randomly decided, oh, this, I don't like this indentation, even though it's right.
Okay, let's do this. Highlight all of these. Let's do these. I'll show you how to do it all at once.
Okay.
So highlight all of those lines in that nested if statement.
Okay.
And I think control square bracket, the left-hand square bracket will undo the indenting and bring them all the way back. That way you only have to hit backspace on each one. So you bring it all the way over to the left.
Okay. Wait.
Oops. Control Z is undo.
Yep.
Yeah, so if you highlight those and control left-hand square bracket, will bring them all the way back.
Yep.
And keep going until there's no indenting left there. So now, one at a time, put your cursor at the beginning of that top line and backspace and enter. Oh, I was gonna say backspace because idle should handle it for you.
Okay, yeah.
You shouldn't have to. So it's a Python specific IDE, so it should always handle. Oh, that time we do have to hit backspace.
Mm-hmm.
Yeah. And yeah, that's just a little pattern to follow to try and do it all at once.
Okay.
But yeah, anytime stuff like this happens, go ahead and stop me, because tracking down problems can be can be more useful than the general logic tips, because you all have had general logic.
Oh, there we go. So now it doesn't like this. We don't want that under this if statement. We want that under every if statement, right?
Yes. So it should be lined up there. Yeah. This is that thing where the C family of languages, curly braces can be aggravating, but tracking down white space is really rough.
Mm-hmm.
So I think the line after that is going to need adjusted as well.
Yeah. All right, we're just gonna do the same thing.
Okay, so for this one, yeah, just tab over once. That's where that goes.
Oh, okay, once. Twice.
So that's actually the problem's on the next line.
Mm-hmm.
So go back and hit enter. Yeah. The same thing. Why is there an indentation error? There's to-do. Yeah, I guess try to redo all of the lines because it's detecting an indentation error somewhere and marking it in the wrong spot.
So
that's main while loop, so one indent. And then for this one, backspace and yeah, let the computer. And here.
I could just backspace it and then just
I don't see anything that would be causing that problem. Player state is equal to walk, colon. So our next line gets indented. Let's check these lines. Highlight this area and see if there's anything that, oh, there's the problem. There was an indent that was off above it. So one more, because that line that's not indented will give you trouble.
so
yeah, and now you can put some spaces back in there. Yeah, tracking down extra white space is
let's just remove all that.
it's an inconsistent use error. Okay, so somewhere the computer got off between, I thought that was still saying indentation error because I just glanced at it and saw the I. It's an inconsistent use error. So somewhere you have 4 spaces and some places you have tab.
Okay.
They're not compatible. So you might have to redo all these lines before it. So I'm thinking one of these lines probably has a tab on it. They're on the for loop for the ground.
Mm-hmm.
So bring that one back out all the way to the left and then redo it with the tabs here. As idle puts in 4 spaces. So if like that was copied from the example, I may have set my text editor to tabs. I thought I had it set for spacing. Inconsistent use of tabs and spaces in the indentation.
Yeah, let me.
So somewhere there's a tab instead of 4 spaces, or somewhere there's 4 spaces instead of a tab. So you might just have to redo all of the lines. Yeah. And what I like to do is unindent everything and then just start at the first one. And as much as possible, so there won't be any problems until you get to the while loop. So they are,
yeah.
the inconsistent is all that's a type of indentation error. So basically
it's
from
all
line
just-
67 to 112. Yeah. And then bring all of that back over and then use the let idle indent as much as you can. Yeah.
Ah, shoot. Oh, that won't.
And you can probably get those comments out of the way. Oh, I think there's extra indenting here though.
Exactly where. Oh yeah, you're right.
And then that line would need indented. Player state equals walk. You can just hit tab now. It should be good.
Okay, yeah.
Yeah, the backspace is for when we get confused, but it can be a lot better to let the computer handle as much of that as possible. And yeah, once again, everybody, if something like that happens, yeah, let me know. We'll track down the problem because that's a more useful thing to see in a lot of situations. And then that one goes back out. Yeah. Yep, right there.
This one
and
goes
back out.
This one goes here.
One more.
Okay. Shooting.
And yeah, whenever that problem happens, that's when curly braces are really nice. It's like, oh wait, I don't miss curly braces at all. Trying to find a white space problem.
This else goes here, right? Yeah.
Yeah, there are advantages to both because if we have curly braces and semicolons, Joe just commented in the chat room that white space doesn't matter at all. Yep, and then I believe that one will be indented at that same level.
This is all down here.
Oh, the clock does need indented.
Huh? Oh,
Yes, those are part of the main loop.
these are part of.
Yeah, the flip method there. The display flip is update the display, update all the images, and then clock.tick also needs indented.
Okay.
Clock.tick is how long to wait for the next frame, or how long to try and wait for the next frame. We do keep that as a loose thing. So see if it runs now.
Okay, there we go. And then you just kind of.
Yeah, so that's my recommendation on that. It's a little time consuming, but I think at this point you've probably noticed programming does require a little bit of patience.
Yeah. Frame is not defined. Might have messed up here because it's not really moving around. Hitting was. It's saying, what was it? Frame not defined. I guess we.
Oh, a variable called frame to tell what animation it was. So I scrolled way up to the top and set frame equal to 0.
Where was that?
Yeah, anywhere way up there where we're declaring stuff. I did it somewhere like around line 10.
So what did you put? Frame equals 0.
And then the very last thing in the main loop, down like where you increment the counter and things, display.flip and clock.tick, somewhere next to those, you can do frame increments by 1.
Which one was the frame? So frame equals plus or frame plus equals 1.
Yep. which is a shortcut for frame equals frame plus one.
It needs to be uncapitalized. Case sensitive.
Oh, yes.
There we go.
There we go. Yeah, so anytime that happens, just stop me and we can deal with those. So one other thing that is super easy. So if you want to go ahead and stop screen share,
Sure.
I'll add in the last part. Did everybody kind of catch what was going on there? I assume everybody's seen an indentation error by this point in Python, right? 2 weeks of working with Python, and you'll see an indentation error at some point. It usually doesn't take long till we hit them. So the other thing I wanted to do, and then we'll take a break because I wanted the second portion to be at the start of a video, because after we do this one other thing, then the next thing is object-oriented programming. So then that organizes the split in the video nicely if we do this before a break. So it goes very, very quickly. And that is that sound file. All I did was ring a handbell. Oh, whoops, I shared my screen wrong. Let me share screen again. And if you aren't familiar with it, when you go to share your screen, there's a checkbox for share sound as well. So now you all should be able to hear this sound. All I did was grab one of my handbells and be like, yep, that sounds like coins. I don't have a good player on this computer. Probably would have been quicker to type the code and just play it there. Did you all hear that? Oh, there it is. It just took forever to load. Yeah, so just a ringing handbell to simulate a coin thing. So this was the point for that history essay we've talked about. The animations and sounds are trivial in video games. So if all we want is to, like, say, narrate an animation, that is super, super easy in video games. Which, by the way, I made a short video. I did like a 30-second history instead of the length requirements, which this is the first time I've given any assignment like that. So on that history essay, as those start to come together, if those start to seem, if those need adjusted, like the time requirements, the time requirement can definitely be adjusted, because that was sort of a guess that was based off reading a 4-page essay. That's how long it took. But I did a 30-second history of video game thing for an example. I believe I stuck it in the assignment for, or in all 3 assignments related to the history essay. So you can watch that and see what I had in mind, and hopefully that'll ease up any fears about that assignment. But the point there, sound is really easy, right? In animation, it didn't really take much there. We just loaded the images in and then told it which image to show. Fixing indentation error took longer, seemed to take just as long as loading in the animations. And sound is the same way. So we can just, basically we just ask for it. Everything's built into our engine. And not just PyGame, pretty much all our engines, that's going to be a necessity. Where did I put it in my example? Just to pull this up and get ready. Oh, I put it down there by the coin. So it's going to relate to the coins. So when I was getting things prepared, I called it coin sound. So I'm going to add that here in the coin variables. I'll put it at the bottom. Coin sound equals, once again, the PyGame library that has all the game engine stuff we'll need. It has a thing called mixer. And that mixer has a thing called sound in it. And then we just say which sound we want. Which, what did I call this? I called it coin_sound. But as you all are probably well aware, renaming a file is no trouble whatsoever. Coin_sound.mp3. Yeah, I used the default recorder on the Windows machine and then just ran it through, and then did a Google search for online audio converter. And the first one was actually a Google product. so there weren't extra ads or anything. It was kind of nice. So there's apparently a Google product. If you just search online audio converter, will convert all your audio file formats, and you can just download the new ones. Kind of came in very useful. So now we have that in our mixer. So all we have to do is play it. And I called it coin sound. So we want that to happen whenever we grab a coin. So when we grab a coin, we'll do coin sound dot play. You probably could have guessed that, right? And that's it. So you can see sounds really, really easy. So as far as that history essay, the one that might have sound nerve-wracking because it's so much different than what you've seen before. I'm hoping it'll be fun and easy and fun and good practice with game engines. But there's an example showing how to do it. That's what you'll do for that. You'll just, instead of typing the essay, you'll basically read the content in as a narration and just say play. And then everything else is animations. You'll see, check out that example. It's in like the reminder for the history essay or the initial assignment for it, or somewhere in there. Other than the fact that it was called Mixer to load it in, you probably could have guessed most of that, right? You guessed that we had something called sound. And once we loaded it into a variable, then all we had to do is dot play it. And obviously there's a dot pause, dot stop, dot repeat, loop, all of those normal audio playing controls you would expect built in. Just to check the official documentation at pygame.org to see the list, but you can probably guess them, especially now that you've seen play is a lowercase p, not an uppercase p. You probably have an even better guess on what the instruction is for the rest of them. Now the player walks a little bit better. Obviously that could be cleaned up and fine tuning adjustments to make the animations and speed align and everything. And when he grabs the coin, we get a sound effect. So a rather trivial example, but that's the components I wanted to start off with here. That's what, so it looks like we did hit what I wanted, everything I wanted to talk about in PyGame. We have our basic load the graphics window, set up the main loop and listen for events, external and internal events. So external events like key presses, the mouse click, that is that quit method, that variable or constant stored there that we checked, that is simply a mouse click at this location of that close button. So key presses, mouse clicks, external events, collisions. As we didn't really see timers, if you check out that history example, that's all about the simple timers I used. But well, everybody showed up right on time for class, or within a couple minutes of time for class. So I'm well aware that you all already know how timers are used, and timers in video games are no different. All you would need is the syntax. And what I usually do for timers is, since I typically have a counter running to keep track of the animation, I just use that as my counter, as my timer. Because I know that when that runs 60 times, a second has passed. So then I can set up times in the game based off how many frames have passed. So timers are rather easy. I feel confident y'all can run with that and get those applied. But if you have any questions with them, let me know. But that covers all the basics, right? We loaded in the thing, loaded in our graphics window, threw some images up there. We were able to fill up this. Right? We didn't know how big the window was, so we had a little image, and we just did some nested loops to put that image, lots of those little images there so they line up for the background, or drawing one big background is obviously even easier than that. Some alignments, put images in for the character, made a move, eventually animated that, have our score incrementing, sound effects. So that was the short list I put together. Basically, everything on that short list I put together for the starting key elements. That's the tools we have to make a game with. We'll have the game engine's going to provide a whole lot of those things. So we just need to work with them and load in the images, open the graphics window, load in the images, move those images around based off external events or internal events. Because when you add in some NPCs, instead of the WASD keys, they're probably going to be controlled by timers. But that's our tools. So that's the kind of wrapping up the first pass at the look of our tool, the tools we have to develop video games with. Does anybody have any questions about that? Okay, so I was hoping to be to this point about 10 minutes ago. So I am getting very thirsty. And then after the break, there's another cleanup thing we're going to do with something that's very, well, I'm just going to say it's pretty much the standard for programming. And some of you all may have seen it, and some of you all may have not, but that's object-oriented programming. And I wanted to do that after the break so the videos line up nicely. And then we have one topic on each video today. So 10 minutes sound good?
Yeah, it sounds good.
All right, so we'll get back to this at 2:31. I'm going to go grab some coffee, and then we'll get into object-oriented programming. Oh, the clock rolled over. Let's make that 2:32. We'll get back to it. See y'all in a few minutes.